Good morning, everyone. May I have your attention, please? The webinar will about to begin. Ladies and gentlemen, good morning and welcome to ITB SES Virtual Talk on Water Research. Firstly, we will start with our video about SES publication. Please enjoy.
Join us and be a part of Generation Restoration.
This World Environment Day.
Restoration starts now.
It's like this.
Trash into gas. What is your pledge?
In a snap.
We are rapidly reaching the point of no return for the planet. We need to replant and protect our forests. We need to clean up our rivers and seas. And we need to green our cities.
We at UNEP, along with FAO and partners, are so proud to kickstart the United Nations Decade on Ecosystem Restoration, to reimagine, to recreate, and to restore the ecosystems on which all life depends.
Hey, aloha. I'm Jack Johnson.
Bismillah ar-Rahman ar-Rahim. It gives me great pleasure today to plant our 1000th tree.
Ich freue mich, dass wir als erstes Land dem Treuhandfonds für diese Dekade Mittel in Höhe von 14 Millionen Euro zur Verfügung stellen.
Good morning, ladies and gentlemen. Welcome to ITB SES Virtual Talk on Water Research. Today on Thursday, 24th of June, 2021, we are very grateful to welcome all of you on ITB SES Virtual Talk on Water Research. Allow me to extend our warmest greeting to our speakers and guests. Executive Secretary for LPPM ITB, Dr. Rino Rahmatamukti. Executive Secretary for Community Services, Denny Willy Junaidi. The Deans of Faculty of ITB, Editor-in-Chief SESTS NT Water, Prof. Snyder, Vice Dean of Human Resources at Faculty of Civil and Environmental Engineering ITB, Hadi Kadana PhD, Market and Business Development Manager from SES Publications, Ms. Mandy Sang. Distinguished guests, ladies and gentlemen, today our agenda as follows: opening remarks, presentation by Prof. Snyder, presentation by Hadi Kadana PhD, introduction from ITB Student Chapter, World Environment Day quiz from SES Publication, and closing remarks. Firstly, we will to invite our Executive Secretary for LPPM ITB to present the opening remarks. Ladies and gentlemen, please welcome Dr. Rino Rahmatamukti.
Thank you, Ms. Mahar. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. Thank you for joining us in our event. This is the focus group discussion series of LPPM ITB, the volume 3. Today we will have discussion about the water research with our prominent guest speaker, Prof. Shane Snyder. Welcome, Prof. Shane Snyder. Prof. Shane Snyder is a professor at Civil and Engineering Civil and Environmental Engineering at Nanyang Technological University in Singapore. So he's a well-known professor, and he's actually now the editor-in-chief of SES Environmental Science and Technology Water journals. So welcome, Prof. Welcome. And we also are delighted to work closely with ACS Publication. Thank you, Ms. Mandy, for realizing this event, as well as Mr. Helwis from Representative Office in Indonesia. Thank you. And I hope that you all enjoy our session today. So ITB has a vision, our rector has a vision to be globally respected and locally relevant university. So this topic today actually is in conjunction with the World, what do you call this, Environmental Day, yeah. So, and then, so we will talk about the water, especially today. And in Indonesia, there are so many problems with the water, especially in West Java, where our university is located. We have the Citarum River that has some complicated problems. So I hope that we can solve the problems together in the future. And we also have Dr. Hadi Kardana as our moderator today. Thank you, Dr. Hadi. Dr. Hadi is also the Vice Dean at our Faculty of Civil and Environmental Engineering at ITB, and he will moderate the session. FGD series LPPM ITB actually is made to build the research culture at ITB itself. So we would like to increase the productivity of our scientists to do more research in many fields. So that's it from me now, and I give back to Ms. Mahar. Thank you, everybody.
Thank you, Dr. Rino, for the speech. Before we continue to capture today's event, we will have a group photo session. So all participants, please turn on your video. Please, Mr. Ali or Mrs. Karina, to help me.
Okay, for the first page, 1, 2, 3. Second page, 1, 2, 3. Third page, 1, 2, 3. Fourth page, 1, 2, 3. And the last page, 1, 2, 3. Thank you, everyone.
Thank you, everyone, for your cooperation. We are going to have a first session on water research by Prof. Snyder. This session will be moderated by Hadi Kardana, PhD. I would like to invite Mr. Hadi Kardana to introduce Prof. Snyder. To Mr. Hadi, time is yours.
You can you listen my voice, Bu Mahar?
Yeah.
Yeah, I'm now in campus, so because of the weather, I think the connection is not too good this morning. So please pardon me if there's some technical issue regarding the connection. Thank you, Pak Rino, Bu Mahar, and welcome, Pak Snyder, Professor Snyder. To our FGD series, yeah. And in this session, we have lectures from Professor Sen for 1 hour. And before we proceed to the lectures, I would like to read the curriculum vitae of Professor Snyder. So Dr. Snyder is the professor of civil and environmental engineering and is the executive director of the Nanyang Environment and Water Research Institute at Nanyang Technological University, NTU, Singapore. For over 20 years, Dr. Snyder's research has focused on water quality, treatment, and sustainability, which resulted in over a gigantic 300 published manuscripts with 28,000 citations. Yeah. And Professor Sen served as the editor-in-chief for the ACS Environmental Science and Technology Water and is a fellow of the International Water Association. Dr. Snyder was featured among the top 25 leading water research globally by Lux Research and was awarded the Dr. Pankaj Parekh Research Innovation Award and the Agilent Leader Award. Dr. Snyder and his team were awarded the Nanyang Humanitarian Award for their philanthropic work in water and sanitation, which has benefited over 2 million people in undeserved communities in Asia. So again, I welcome you, Professor Sen, to this focus group discussion. I hope we all have benefit from Professor Sen lectures. And without further ado, I let the time to Professor Sen to give his presentation. Thank you very much.
Thank you for the very kind introduction. Can everyone hear me okay? Is it okay? Okay. So first of all, I just wanted to thank the organizers for inviting me. I wish I could be in Indonesia, in Bandung. I've been there many times actually, but not for a year and a half like probably all of you. So hopefully next time we'll be able to meet in person, and certainly when we open up, I'd be happy to see many of you come into Singapore. So before I get into my actual lecture, just a few words about the new journal. So we opened up this new journal last June, so just over 1 year ago. And within the first year, within the first 12 months, we received 500 submissions, and we've published over 150 manuscripts, and that's in 6 months because the first issue was January. And our articles have been downloaded more than 90,000 times. So the journal is off to a very good start. And one of my own goals is to have more representation of what's happening in Southeast Asia. And I'll talk about that a bit today. Obviously, Indonesia being the largest of all the countries of Southeast Asia, there's a lot of work going on, and I'd be happy to work with you to get your good work published in ES&T Water. All right, make sure all right, so I'm not going to go into detail. We cover all aspects of water, whether it's policy, treatment, remediation. If it is related to water, we're very keen to see your manuscript. We already talked about my background, so I'm not going to go into it again. I'm fortunate to have 3 associate editors. Prof. Qinghua Huang, she's at Georgia Tech in the United States. Prof. Jörg Dreves from Technical University of Munich in Germany. And also Professor Min Yang, who is with the Research Center for Ecosystem Environmental Sciences with the Chinese Academy of Sciences in Beijing. And hopefully with the journal's growth, we'll be able to add some new people. Now, along with myself and the other 3 editors, we have a very big editorial board, and something maybe all of you that are interested could think about, helping with the journal and peer review, and then aspiring to be on the advisory board and later as an editor as a natural progression. And hopefully you can see in this map, actually, most of the editorial advisory board is in Asia, which I think is very unusual for the journal, but yet, again, so much growth that we all can talk about and look forward to sharing together. So again, you can find this online. I find the alerts helpful myself to follow the journal and what's the latest publications. So enough about the journal. I'm happy later to take questions, or you're welcome to write me an email if you're interested in the journal or how to submit. So for the rest of my time, I had a very broad topic to speak to in water. And I have a really eclectic background, actually. It's hard to believe. I actually started as a chemistry major, and then I switched to toxicology. You'll see a bit about that. And then I worked for a water agency in the United States for a decade. Then I went into academia. Around 2008, I started visiting Singapore, really enjoyed it. And now I'm a permanent resident of Singapore, and I've been living there now for 4 years plus. So one of the things that's great about Southeast Asia is how much differences we can see within a relatively small amount of geography. So I wanted to talk about some of the work we've done trying to implement best available technology in some communities where they have really great needs for water and sanitation and solid waste. I'll touch on that even though we're mainly about water. So all of you in Indonesia, Malaysia, I see we have a few people from Korea, other places, all of us may not realize that Southeast Asia is quite big. We're 650 million people. So it's a very large number of people, but yet in a relatively smaller amount of land. And if we look at the growth of Southeast Asia, it's pretty incredible. Most of the populations have quadrupled or went up fourfold since 1960. And of course, as I mentioned before, with population followed by the Philippines. So again, there's a lot of opportunity in water and infrastructure, and I'm excited to hear that the university in Bandung is looking at this area progressively. So at least before the pandemic, I think all of us in ASEAN were enjoying very rapid growth. I don't see that that'll end. Of course, we've all struggled with this horrible pandemic. But what we've noticed and what people around the world have seen is that many of the Southeast Asian countries have done very well in growing their GPD. And of course, Singapore has an interesting story too. It's only a 50-plus-year-old country. So here is the map of Singapore, if you will. And in the 1960s, about 582 square kilometers. We're at the very southern tip of Malaysia and not so far away from Indonesia either. So by 2018, Singapore had increased its size by 23% by land reclamation. And today has a vibrant population of almost 6 million, but very high density. We have about 7,800 people per square kilometer, which makes it one of the most densely populated countries in the world. Now, this is where the story, I think, gets interesting for water. Obviously, Singapore, we enjoy a very good amount of rainfall, about 234 centimeters per year, being very close to the equator. But with that density of people, it makes it very difficult to have water catchment, to capture that rainwater, to use solely the rainwater. Therefore, Singapore has a diversity of water portfolio, and I'll just touch on that today. But I'm always moved by the founding father of Singapore, Lee Kuan Yew. And early on, as he was founding the nation, he said that every policy had to bend to the needs of our water survival. And how true it is, without water, it's very hard, if not impossible, to have a vibrant economy and not just have water, but have reliable, safe, and secure water. And Singapore has come a long way from the 1960s as one of the poorest countries in Asia, had a lot of difficulties with water rationing, inadequate sanitation for the population. And again, Lee Kuan Yew made that one of his primary goals to improve. Today, Singapore has really advanced their water security and technology. New water, which is what brought me to Singapore in part. We can recycle our wastewater, or our sewage, if you will, into very high purity water. And most of that water, most of the new water, is used in industry, not consumed. There's some back into the drinking water, but most of it's consumed by semiconductor industries and oil and gas, etc. In the behind picture, we have ocean desalination. Singapore International Water Week is actually happening right now. I gave a speech a few days ago, and I also got to hear one of our ministers speaking about the future for desalination. So it'll remain important for their water portfolio. Now, of course, Singapore is a highly developed country. They've done quite well in the last 50 years or so. But still, there's always a challenge that you may not have thought about. This is a photo of a red dye that was released from some industrial or private sector activities, gets into the canals, but those canals go into reservoirs, and those reservoirs are used for our drinking water. So when we see spills like this, of course, we become very concerned and want to make sure it doesn't happen again. And with in Singapore, we rely on water from Malaysia. We import water. So at times things can happen. There was a chemical spill in Malaysia, which inevitably turned up also in Singapore's drinking water. And I'll talk a little bit about how we dealt with that. And of course, nobody can escape climate change. And maybe no country has as much to lose as we do in Southeast Asia, and Singapore in particular, being a very small country with heavy land reclamation. Any gain in sea level rise will quickly erase the engineering. And not only that, but if you look at the droughts that we do have, even though we have a lot of rainfall, we still go through periodic droughts that are very difficult to manage the water supplies. So this is a photo of one of the dams in Johor Bahru that was at 16% of its capacity. So fortunately, we were able to use desalination and recycling, but it's important to realize that climate change is real and is impacting our water supplies. So again, can we turn this into opportunities as we learn more about how the ocean's water quality will change? Can we build better systems to be more resilient against climate change? And can we use those technologies to help other people in other communities that face very similar challenges? So we don't have to look very far, though, within Southeast Asia to know that a lot of our fellow people in our region do struggle with safe and secure water. It's been estimated that up to 140 million people of Southeast Asia don't have access to safe and reliable drinking water. And in sanitation, it's even more daunting. The Pacific region, the Asian Development Bank has estimated that maybe up to 80% of wastewater is discharged without treatment. Of course, that has a subsequent impact to the environment, and it can also impact human health if we are drawing drinking water downstream. So here we are, up until the pandemic, notwithstanding, seeing a per capita income growth across the region. And generally that results in a turning point. They call this a Kuznets curve, whereby we become more cognizant of the environmental challenges and we spend more money to try to improve our environmental situation. So just a few photos, and if we look across Southeast Asia, obviously the Mekong River comes up a lot of discussion, tremendous opportunities for shipping and for hydroelectric, but certainly challenging to manage the environmental impact. The Tonasep Lake in Cambodia is another body of water that has been impacted by urbanization and changes in weather patterns, and some experts wonder if it'll ever come back to the way it used to be. Metropolitan Manila is very high density, and we are beginning some work there ourselves with my institution, NURI. Hopefully as soon as we can get travel out into Manila. And this is just showing, some urban canals taking water out into the bay. So we know that there's a lot of opportunities for remediation, etc. And I just want to make one point on food supply. Maybe some of you probably realize that much of the rice that we have in Asia comes from Thailand. And that increase in productivity in Thailand has come with a commensurate increase in pesticides. So the amount of pesticides imported to Thailand from 2000 to 2010 has went up roughly 3 to 4-fold. So it's important to have monitoring programs to make sure the environment is protected. And of course, we are working very closely with many of our partners in Malaysia and Indonesia on palm oil. Palm oil is extremely valuable, extremely important. And I think the palm oil industry is doing a good job to work closely with universities and partners to be more sustainable and avoid pollution. And lastly, I wanted to show you a photo that I took. This is somewhere not so far from Bandung. And I was excited to meet a company who was working in batik, in textiles. And they were showing to me how they were able to treat a very difficult water into a quite good quality water. And we talked about how the new technologies may be able to even save them more money and produce an even better quality water. So it was exciting for me to be in Indonesia and to see that excitement from the people on the ground who are developing these treatment systems. So back to kind of my closing comments on Singapore and what's going on. There's lots of challenges around us all through Southeast Asia, but I think this will drive innovation. And like the Institute of Technology in Bandung and like the Nanyang Technological University, I think we could partner on some of these items, and there's no shortage of need throughout our region. So with the time I have left, let me go through and give you just a few examples. So let's talk about some of the very specific technologies. You heard at the beginning, I'm fortunate to be the executive director of NURI. Our institute is about 300 people. We have about 80 faculty members, and we work on a very diverse amount of water and solid waste recycling topics. But my most favorite thing I do actually is philanthropic. We have been quite fortunate to receive an endowment from a family in Singapore to help us disseminate, or I should say, to help us implement NURI-based thinking and technologies and education in parts of Asia where communities have reached out and asked us for some help. And we have done, I'm going to show 2 projects in Indonesia that were very successful as well. So first of all, just a quick word. I wanted to share with you a quick couple of words on advanced monitoring. This is actually my own area of expertise. I won't get into endocrine disruptors so much, or the things I usually work on. But I did want to mention, you know, we have the capability to do pathogen testing. And for all of my career, I used pathogen testing to test water treatment to make sure water treatment could remove, disinfect our water and wastewater. But now with the pandemic, things have changed a bit. We're looking at different ways to measure all kinds of trace contaminants, but also we're also getting more into how we use that technology in the pandemic, especially when we're trying to find a unique case in a community. I'm about 1 slide ahead of myself, though. This is about the chemicals. I just wanted to show you that on the far, hopefully the far right of your screen. Remember that I mentioned we had the chemical spill that occurred in Malaysia and quickly came into Singapore's drinking water. We were able to use our modern analytical technology to literally within minutes or hours, know what was in the water and at what concentration. So again, you know, I started talking about the pathogens. We do a lot of work in bioassays. That's my own background. I, again, won't get into that today. But I wanted to show you a little bit on wastewater-based epidemiology for obvious reasons. Without going into a lot of detail, we've developed a way to take a single sample and we can look for a positive, COVID-positive patient in about 50,000 population, even potentially 100,000 with our newest digital drop PCR technology. So I thought there's some of you that may be in water engineering. I just wanted to give you a really quick glance at something, it's brand new data. Now, all I want to say about this, because we have a diverse group of audience, but we use PCR predominantly for the coronavirus identification and quantification. So this is a genetic tool. It's looking at a portion or maybe multiple portions of the genome in the virus. But what we realized was that, now this is using a surrogate coronavirus, it's still a pathogen, but that actually the PCR was giving us false positives, if you will. The PCR was not telling us if the virus was inactivated or not. So we had to go to what we call a focus forming assay, or FFA. And you can see it makes a huge difference. If we just look at ultraviolet, we would be at about a 35 millijoule per centimeter square dose for 4 logs of coronavirus inactivation by focus forming assay, by viability, where we'd be somewhere above 80 millijoules per centimeter square if we only use PCR. So it's just interesting as we look at this, and I think this is my last example. And on the left, it's a little bit tricky to see. We're trying to calculate a removal rate of a model coronavirus by chlorination. So we had a free chlorine residual, free chlorine at 2 milligrams for 30 minutes, and basically we didn't even get 1 log removal. But if you look at the right of the screen, this is when we took viability. We used focus forming assay, and we can see that we were able to quickly get 7, 8 log removal of the coronavirus by free chlorine. And if you're curious what's in the center of the screen, this is a TEM, this is electron microscopy image of the coronavirus at the top. Then you can see after chlorination, you can see how the protein capsid of the coronavirus is completely not living. And the summary words here are that PCR is great for detecting the virus, but it doesn't tell you at all if that virus is alive or viable or not. And I had one last one here. Is just we had a lot of interesting data on membrane filtration. I don't want to get deep into that, but here we looked at 2 different types of membranes. One is a PES type, and one is a regenerated cellulose, or RC, both 100,000 kilodalton cutoffs. And we noticed 2 things, that depending on what the material the membrane was made of would make a big difference in virus rejection, and whether the membrane had been used or was brand new. So anyway, just a preview of data we hope to publish, hopefully in ES&T Water later this year or next year. So let's talk about some of the technologies beyond what we use to monitor. In biotech, we are very keen. We heard from the Minister of Sustainability and Environment of Singapore last week, saying that they wanted to be energy neutral in their water and wastewater reclamation. That is definitely a possibility with modern technology. We also want to be cognizant on net zero waste. Things like food waste in particular are big for us. And then the last area is the rapid biological assays for safety assessment. And that's my own area of research, but unfortunately not enough time to go deep into that today. So let me just I'll just try to give you 2 examples of each of these major technology platforms to let you know what we're doing and how we hope to deploy it in the region. So this first one is called Anamox. Probably many of you have heard of Anamox. It's a natural bacteria, but it's a very delicate bacteria. And what it can do is it can convert ammonia to nitrogen gas without going into nitrate, which means it doesn't require the heavy aeration or oxygenation, which is the predominant energy consumption in a wastewater treatment plant. But these are very delicate bacteria. They're hard to grow and difficult to establish in mainstream. But at NURI, we developed a new type of membrane bioreactor. We use 2 different membrane bioreactors tandem. One is anaerobic, where we can get biogas and we can we can get energy recovery from the A stage, the anaerobic. That actually helps us to remove some of the carbon, enriches the ammonia, and allows the Anamox to flourish in the B stage. So this is now being demonstrated in Singapore. It's at a very large scale and hopefully commercialized. In food waste, in Singapore, we actually have a really high amount of food waste for on a per country basis or per capita basis. Partially a lot of strict food safety laws, but also a lot of delicious food that's put out and not all consumed. We developed a technology called EcoStomach. And what this does is used as a fungal mash. So we seed a fungus that is actually produced within the EcoStomach technology. And then we use that fungal mash to do ultra-fast hydrolysis. So in about 8 hours, we can completely convert food waste into solid and liquid biofertilizers. And this was developed by Prof. Liu Yu at NURI here at NTU. So how do we get some of this out into the communities? Well, I wanted to show you one. This was in Sumedang, so this is not so far from Bandung. We actually helped design and build a water treatment system, and this was in a partnership with ITY and LIPI. So we were turning high COD wastewater into biogas, and what we were able to do is capture this waste that was destroying a river, and through anaerobic treatment, create biogas that now supplies 92 different homes. And we understand that that system has been replicated. In Sri Lanka, we had the Kandy Lake. This is a UNESCO World Heritage Site. It was highly polluted. There's a lot of tourism, a lot of pilgrimages to Kandy Lake. So we used our funding to help design and implement a wastewater treatment system, but we also promoted and helped design floating wetlands. And this actually was quite a successful project. We won the ASEAN Outstanding Engineering Achievement Award in 2017, and it helped the city of Kandy secure money from JICA and World Bank to build full-scale water treatment now for the city of Kandy. I said I couldn't help but to say a few words about my own research. So what you see here is a glowing zebrafish embryo. So what we can do, or what we do in our laboratory, we use zebrafish embryos in different ways to look at water quality. So we can use both human cells or zebrafish cells or zebrafish embryos, and it allows us to do a variety of mixture toxicity screening. So not just one chemical at a time, but the entire mixture together. So where are we implementing it? Well, just before the pandemic, my last trip actually was to Kathmandu, where we are beginning a monitoring program in Nepal in the Bagmati River. So this is a river that Himalayan mountains, so quite pure, glacier, snow, melt runoff, and then it moves down through the urban areas of Kathmandu and eventually into India. And so we're helping them to build this new monitoring program and then hopefully build a treatment system at a point source. NURI is really strong in membrane technologies. This particular area is led by Prof. Wang Rong at NTU. She is the director of our Membrane Technology Center. And that group has done tremendous work on developing novel membranes and looking at how they can be better designed, the modules engineered in new ways, as well as different sensors, including for biofouling. So one of their most notable achievements, they were able to build and commercialize what we think is the world's first biomimetic membrane. So this is a membrane that's based on natural chemistry in the human kidney called aquaporins. And the aquaporins work just like they work in your kidney to help channel salt out. And in recycled water, brackish water, could actually lower the energy consumption by about 50%. So this began as a flat sheet, typical spiral wound flat sheet membranes. And now Prof. Wong and her team have developed hollow fiber versions, which is being funded by the Singapore government. And hopefully we'll have more test bedding and scaling data soon on the pre-treatment of seawater and other applications. One that I found particularly exciting from my own history was this nano filtration. Without a lot of detail, nano filtration basically can remove almost anything except for sodium chloride, very small salt atomic level. but it can even remove divalent ions like magnesium and calcium. So we built a hollow fiber version. You can see that it is a very energy efficient and very effective. In fact, if you can imagine, we can use this magnesium rejection to pre-treat seawater and potentially produce a magnesium bouillon or purify magnesium from the ocean, which could also help subsequently offset the cost of ocean desalination. So how did we implement? We actually have installed, before the government unrest, unfortunately, in Myanmar, we installed what we think may be the first nanofiltration system. This was in Mandalay. So the people in Mandalay had very hard water, very contaminated water. It was groundwater, but yet it had pathogens and it had very high hardness. So we built and designed an NF system, and we got it installed, and it's still running today despite all the challenges the people of Myanmar have underwent. Another example also from Myanmar is from Yangon. So in this case, we were looking at a shallow aquifer, and the people were using this water for their drinking, etc. And it is a very, you can hopefully see the chart, it is a very salty water, and also polluted from various industrial activities nearby. So we decided to use reverse osmosis. I think what made this special was that we put in our own sensor technology and control systems so that we could monitor and control the RO system remotely. And we won yet another international award for this design. Another area that we're quite strong in is material science. I personally like to work in advanced oxidation. Today it's advanced reduction, another important area of study. And to do so, it's enabled largely by different types of catalysts. Sort of like the catalytic converter in a car, we're building what I would call a catalytic converter for water. Especially if we're operating with no oxygen, we can begin to do reduction. So there's a lot of things we can do, even resource recovery. So I just show here two examples. On the left is a partnership with a company called IXOM. They produce a magnetic ion exchange resin, and they came to our institute and asked if we could help them to pilot test it in Singapore, which is a unique water with its warm, tropical, high dissolved organic water. As well as maybe help them improve their technology through co-creation, which has been going very well. On the right, I show a material that we developed ourselves at NURI. Professor Hu Zhao developed this particular polymer with different ligands, which can absorb metals, and then it can actually be regenerated by shifting the pH with carbon dioxide or nitrogen. So we can use it for remediation, but we can also use it for resource recovery. Another area that I'm very keen on is inorganic membranes. Now these are for filtration, not for desalination, but Singapore has built the largest ceramic membrane filtration plant in the world, just adjacent to the NTU campus. And we really, I mean, it performs amazing. But the question that I had was, well, can we translate that into something that a community could use? And the answer, we're very excited to partner with a company called Avivo, quite a big company. And they have a silicon carbide flat sheet membrane. And it's so simple, actually, even just for backwashing, we can use pressure washing. The flux is extremely high. And actually, it was cost comparable to sand filtration when we looked at the entire infrastructure and life cycle. So again, this is what I mean about, how do we get this kind of great technology into the hands of people who need it the most? Well, we're trying. So hopefully in another year, if we get together, we'll let you know how it went. But so far, the results look outstanding. But sometimes the most high tech isn't the most critical. In Nepal, we actually built a system to remove arsenic. This is in Nawalparasi. And you can see, hopefully, a photo of me down in the corner where we actually decided to use nails. These are iron-based nails. We oxidize the water, or aerate it. We go through multiple stage sand filtration, very, very simple, but very effective at removing arsenic. And more importantly, we offered an education program to the people who some of them didn't realize the dangers of arsenic. And yet another, just to make a quick word, we're running out of time, but this was another one we did in Myanmar, actually. And if you look closely at the photo, you may see some of the same people. We actually had a neighboring village that saw the RO system, asked if we could help them. And we looked at their water, which was very different. This was more rainwater, surface water collection. And we decided to go with carbon, activated carbon and ultraviolet light, which has been functioning very well for that community. In modeling, of course, AI, machine learning is becoming paramount, even in the water sector. Whether it's modeling or hydrodynamics, building new types of sensors or sensor networks, even autonomous water treatment, and again, being able to control these systems using artificial intelligence and or machine learning. So one of the examples I thought I'd mention, our minister was speaking recently about covering the reservoirs in Singapore. So the drinking water reservoir at Tengay Reservoir was covered with photovoltaics. But before that was done, we needed to model it to understand how, if at all, it would impact water quality. So there was a lot of, if you will, high-tech water quality monitoring that went into that decision-making. We also do remote sensing of the coastline of Singapore, and now looking at flooding and modeling for flooding, again, to consider the changes that we'll endure under climate change scenario. Even though we don't use groundwater for drinking water, the groundwater in Singapore is very important, even to things like tree stability, where we developed a sensor and modeling system that can predict whether a tree is susceptible to fall, and that way we can cut it down before it hurts somebody or causes other types of damages. So modeling, we've done a bit of modeling in Yogyakarta, actually. We engaged with ITY, and we looked at a particular village, Watugaja village, where we were doing remote sensing and looking for water at quite high depths after the earthquake had a fractured karst system, and we were successful with that project. Also near Yogyakarta, we built a system that would essentially do infiltration. It captures stormwater, infiltrates it, and then through a well system, filters the water, then we treat it with ultraviolet light. And since we built our first well, the government has built 2 more wells within the same Dolene structure. So we are very happy to see our work being replicated and to be embraced by the people. And one last fun photo, I had a chance back in 2019 to meet Paku Alam and the Director of Clean Water Supply from the Ministry of Public Works in Yogyakarta. So hopefully within another year, we're able to get together again, whether it's in Singapore or Indonesia, but I sure do miss those in-person times. So lastly, I know I'm about out of time, but maybe I'll leave you with a few words on solid waste. I know we're here to talk about water, but clean water and solid waste are very much related, especially if you're thinking about landfills or even incineration and dioxins. We have a research test bed at Newry. This is a gasification technology. So as compared to normal incineration, it operates much, much hotter. And we can even feed in the bottom ash from typical incinerators, which we currently use in Singapore. We could also put in sewage sludge. We can, from that, create what we call the gasification slag. But this gasification slag acts very much like sand. And maybe some of you on the phone realize that in Southeast Asia in general, there's a bit of a shortage of sand, especially for Singapore. So being able to take our waste and create new sand is something that's very valuable to us and has been praised by the government. They've used the new sand or gasification slag from our institute in part to create the sidewalk in front of the government's environmental building. A brand new area that we've had good success is in carbon sequestration. Now, this is an interesting one. We actually are combining the bottom ash and fly ash from our incineration facilities with the brine, the ocean desalination brine, which is quite rich in metals. It has a quite high pH, so it favors the formation of carbonates. And these carbonates allow us to sequester CO2 and provide a very sustainable building material. And last but not least, one of my favorites, and this actually took me several trips to Indonesia to talk with other people who are working in this space about plastic waste. Obviously, all of us have heard about the plastic waste and the great ocean patch of plastic floating in the ocean. We have some technology that can convert mixed plastic waste into 2 grades of diesel. And if you're thinking that's not very novel, you're right. Forming diesel from mixed plastic waste is actually pretty easy to do. But where we add value is we have carbon vapor technology where we are able to use our own fluidized catalyst and create carbon nanostructures from the carbon vapor, like carbon nanotubes, for instance, that can be used in batteries, other high value materials. And lastly, we've realized that even the gases that are produced during the pyrolysis should not be burned. We used to use them to burn them to fuel the pyrolysis, but actually those gases are so valuable, we're better off not to burn them and to use other energy and to collect those gases that can be used to make plastic again. So again, there's plenty of problems with plastic around Southeast Asia, and we hope we can engage with others that are interested in that kind of recycling effort. So I think I've taken up all my time. Again, it's never the same as being live in person to see all your smiles or head nods or whatever. But I think there's so much bright future once we get past the pandemic and all the destruction it's caused to work together. I'd love to work again with the group in Bandung. And again, I know it's a big international group. So at the end, there's my email address. And there are 2 links. And hopefully you can get a copy of these if you want them. It'll let you see what the laboratory is like and what we do, a little bit more detail and more about the people as well that work at NURI. So thank you for your time. And if there is opportunity, I'm happy to take a question or 2, but I leave it up to the moderator. Thank you.
Thank you, Prof. Sen. It's very enlightened lectures. Yeah. You have very wide range of research from the advanced one into the practical one. So I'm very happy to see you already have many activity here in Indonesia. Yeah, Professor Sen. So we already offer a question to participants, Professor Sen. So I will read out, I think we have 4 questions right now. So I will read out. The first question is from Professor Chandra Setiadi. How is your opinion on the wastewater-based epidemiology as a useful tool to track SARS-CoV-2 and support public health policies, especially in developing countries like Indonesia? As you might aware that most of the sewage in developing countries discharge directly to the rivers. I think this is the first question from Professor Chandra. I think this is your college, yeah?
Yeah.
So please, your response, Professor Sen.
So it's a great question, and I do think it has value. When we think about even the cost to do COVID testing of the population, it's quite expensive. And by doing the wastewater, if it's collected, I'm assuming it has centralized collection, you can get a lot of information about how many people within the population are positive. And as we know, a lot of people have no symptoms. So it also gives us a good amount of information about asymptomatic occurrence. Now, I will say, I think the highest value is when the pandemic is starting or hopefully ending, because it allows you to know if the infection rate is going up or changing. If it's already at a very high level, it may not be super helpful. But I think as we get closer to having lower incidence, it's very good for knowing what communities may have a higher rate than expected.
Yeah. And I think Professor Chandra already has a follow-up remark. Yeah. So he mentioned about the Nyuri tofu digester in Sumedang is still challenging and facing a number of bottlenecks. So his PhD student is now working on it. So he will discuss with you personally later. Yeah. so so let's move to the next question.
It's good to know. It's good to know. We know that, by the way, with food waste, the biggest trouble we usually had, even with the one in Sumedang, is scrubbing. Scrubbing the sulfur is very tricky. So yeah, so I'd be happy to get that email and talk about how it's going.
Okay. So next question is from Thailand. I think, correct me if I mistake your name. Lamtong Chenchom, yeah. So Dr. Lamtong has follow-up question also. So I will read out the question. There are tons of nanomaterials which have been published in journals, but the scale of their production is rarely reported. I'm not sure if nowadays how much of them are really employed in the real wastewater system. And the follow-up is, as you are an editor of ACS Water, what we should focus on most between just publishing these nanomaterials versus developing the real system? And in his opinion, the materials in the lab scale are rarely implemented in the real large-scale system due to the high cost and small amount. Could you please give an opinion on this? Your
Another
response.
Good question.
Yes.
So first of all, I totally agree with the comment. There is a lot of work published on nanomaterials nowadays, microplastics, now nanoplastics, and it's very hard to get production statistics, industrial statistics. And in fact, a lot of these compounds are shed. In other words, it's not that they're produced, not all of them are produced, like the nanoplastics are just a byproduct of the wear of plastics in general. So it's really hard, I think, to get a good handle on how much nanomaterials are possibly out in the wastewater system. But I do think toxicology testing is a good way to look at it. If we had, with fish or with the cell bioassays, there are ways to trap the particles and look at whether or not they have health impacts. As far as the journal, it's a good observation. So a lot of the science, I think, that is published is hard to apply. And I know that for a fact, coming as the leader of a large water and environment research institute, we are fortunate if we can get, a few of our inventions to be commercialized or to go into full scale. So I think it's always hard, but I don't think that should limit us publishing. So we are interested in publishing fundamental science, but I agree there should at least be some acknowledgement if the team doesn't think it can be easily scaled up or would be expensive. That's often a peer reviewer will catch that, could limit the paper. So it's better for the author just to speak about it, to say, hey, this is very fundamental. We don't know the full implication to scale up.
Okay, thank you, Professor Sain. So the next question is from Nurnofilia. Nurnovilina. Yeah. She's wondering about sludge treatment management in your pilot scale anaerobic treatment. With the ultra-fast hydrolysis, is it cause increasing of sludge quantity? So this is direct question, I think.
Okay. So it's a good question, Lena. For us, I guess we end up getting a lot of water out of the system, liquid. So we get liquid and solid, but there's no waste because even the solid is used as solid fertilizer. So I'm not sure if it causes an increase in the quantity of the sludge. I wouldn't expect it because when the food goes in, it's pretty much, it's not high. It looks like solid. And so when we hydrolyze it, it becomes more like a paste and a liquid. So we get these two streams coming out of it. So I would actually think that intuitively reduce the sludge quantity. But regardless, that sludge is valuable, so we still use that as a fertilizer. So the system is net zero waste, actually.
Okay. I think next question is from Puspa Hairani. She want to ask you furthermore about what did you do on locating the water resource when earthquake or disaster happened? Water source, I think, yeah. Is it only earthquake, and after the earthquake, did Nuri build something to help local people to access to water? Or what did they do or technology used in that situation to help supply sanitation and drinking water? Because sometimes the mobilization and of the technology is a bit hard.
Yeah, absolutely. So I remember in the last earthquakes, we wanted to help out and to come in very quickly, even in Lombok. We went to Lombok after one of the earthquakes. And it's not easy to deploy that kind of, in the case what we did with the system near Yogyakarta, I mean, we had to drill a 100-meter well. So that's not something we could do quickly. We had to do, look at the geography and look at where was the best place to drill. So it wasn't an immediate response, unfortunately. That's something we were interested in doing, but we just really aren't set up to do that. We're a small group. So we usually work with a local community, and that was the case in Indonesia after the earthquake when the aquifer was depleted. We were able to help find a new source of water from the ground and help with the infrastructure, all the pumping. So that's what we did in that case.
Yeah. So Professor Shane and all participants. So now I welcome to direct discussion. Yeah. So previously we discussed about text questions. So maybe now I offered all participants to raise the question directly to Professor Shane, if any. Maybe Professor Chandra would like to have some more detailed discussion. Yeah, please.
Hi, Shane. So I visited Nuri some years back when the Ang Wong Jin was the director. So it was probably 4 or 5 years ago. So things are we will have to do again because of the tofu wastewater is a challenging one, and it is of course difficult because of a rather small scale industries. But I think we have to deal with that. I think it might be we can discuss more later about how we can help the small scale industries to reduce the waste, but with the appropriate technology, and probably we can do also by the local industry. So that's a great started, but we have to follow up and to make it better and to help people.
Yeah, good point. I agree.
Thank you.
So thank you, Professor Chandra. So maybe I will ask you a question, Professor Sen, because I'm interested you as also chief of editor. Yeah. So do you have any tips and tricks easy publication during pandemic era? So what is your tips and tricks now?
So I guess first of all, my best advice, there's a few simple things I always advise people. First of all, is to write a good cover letter. It seems so silly, but at least for me as editor-in-chief, I look at every single cover letter. So I think that cover letter, the reason I say it's so important is because you have to convince me that the paper is worthy and good quality for the journal. And I'm certainly not an expert in every single field of water. So the cover letter, when I read it, I like to hear the authors talk about why is it novel? What is new about their work that's different from other things that have been published? And I'll give one extra tip. One of the best things you can do is to cite papers that were published in the same journal, or say ES&T family journals. It just lets me know that you are familiar with the work that's been done in your own field. You know some of the other authors, and then this is why your paper should be published in our journal. And those cover letters are very powerful. It's not the end all, because of course, from that point, it has to go to peer review, but at least gets through that first step of that pre-sorting, when we're only able to publish maybe only 20 or 30% of the papers we get. So it can make a big difference.
So 2 valuable tips, yeah. Cover letter and cite the same journal, yeah, Professor saying. Any particular during pandemic, Pak?
I think so. During the obvious thing that's been a lot of work during the pandemic has been on the wastewater monitoring for COVID. There's been hundreds of papers from all over the world. And I think that at the end of this, there'll probably be more surveillance type programs developed. I think I would certainly think so in Singapore, to try to watch and be prepared for the next pandemic, which is unfortunately inevitable. But yeah, so a lot of papers on COVID.
COVID, yeah. Because now we have difficulties regarding the field work, yeah, Professor Sin. So maybe the result may be affected by that difficulties on that field work.
Yeah, that's true. So we do see, like, I guess, a bit of a downturn, because all of us, myself included, were locked out of the laboratories for some people 6 months, some people more than 6 months. But on the other hand, I think a lot of us are getting some of our older data published that we haven't had time to deal with before. At least that's what I did.
So that's another trick from you, yeah. So I think if there's no other question from other participants, I think I will conclude this session. I thank you, Professor Sen. We thank you, Professor Sen, for sharing us your experience and also some insight regarding the how to publish journal, yeah, good publication, yeah. I hope your sharing session will again benefit to us all. So thank you very much for you and all participants to join this FGD. So I will return the time to you, Pak Rino and Bu Mahar. Thank you very much. Bye-bye.
Thank you to Professor Snyder for the presentation. And the next agenda is introduction from Itv Student Chief.
Okay. Good afternoon, Prof. Shane, Dr. Hadi, Dr. Denny, Dr. Rino, and LPPM ITB, Ms. Nandi, Prof. Wahyu, and to all participants. My name is Rasha, and I'm the president of ACS ITBSC for the next 1 year. I feel honored having the opportunity to attend this FGD series. Also, I'm here representing ACS ITBSC. I would like to introduce ACS ITBSC to you through a video which will be shown. Thank you.
American Chemical Society Institut Teknologi Bandung Student Chapter, recognized on October 12, 2020 by the Council of American Chemical Society, is the first international student-led organization in chemistry and related sectors in Indonesia. In our first year, we have more than 30 active members majoring in chemistry, pharmacy, biological engineering, and many more. Kickstarting an organization may be easy, but sustaining it is another story. With the help of American Chemical Society and Institut Teknologi Bandung, we were able to build a constructive environment for every member. This past year, we had various intimate talks covering versatile topics with leaders around the world to strengthen our soft skills in an event called Internal Forum. Not to mention our classes tailored to every member to get their hands on and discover more about project management, marketing, copywriting, treasury, public relations, human resources, and many more. Not only did we develop ourselves, we also strove to create a greater impact for society. We hosted 4 science-related free webinars and workshops with more than 3,000 attendees worldwide, made possible with the help of our collaborators. The fact that ACS ITBSC is an international organization is both challenging and fascinating for us. American Chemical Society helped us broaden our network by connecting us with another international student chapter. Recently, we had a cultural exchange event with ACS University Technology Malaysia International Student Chapter, where we gained a lot of new perspectives of the 2 different countries, despite being held online. We hope that ACS ITBSC will continue the journey alongside other student chapters, chemistry student organizations, and everyone who shares the same spirit with us.
Thank you, Ms. Rasha.
Okay, so that is a quick introduction from ACS ITBSC. Thank you for your attention, and I leave it up to the moderator.
Thank you, Ms. Rasha, for the introduction. And we will continue to the agenda is short presentation by Hadi Kadana, PhD. To Mr. Hadi, and yours.
Allow me to share screen. Okay, ladies and gentlemen, Professor Shane. So I would like to talk about the water research in ITB. I myself belong to Faculty of Civil and Environmental Engineering. So I belong to the research group namely Water Resources Engineering. So this is depicted in the unit. We are dealing with the infrastructures. Yeah. So maybe I will quick review about the water issues in Indonesia. Yeah. Ladies and gentlemen. So maybe differentiate with Singapore. We have a very big landmass, and we have 131 river basin. So each river basin consists of few until 10th of catchment area, and now we have almost 40,000 catchment area. And then we have, like Singapore also, we have abundance of rainfall, average about 2,400 millimeter, and our reservoir is only 54 cubic meter per capita. Yeah. So this is quite small compared to other countries, and 90% of our infrastructure regarding water supply is for irrigation. Yeah, and we have catchment area that have environmental degradation with lesser forest coverage, and we have more than 65% river is polluted. Yeah, so this is very big issues in Indonesia. Yeah, so and also we have issue regarding the irrigation and the crop. There we have very small productivity, and although we have very large amount of paddy field, but it's very small compared to the palm to the palm, yeah, for palm oil. And we have decentralization of management regarding the water management. Yeah. So irrigation, 34% is by central government and mostly governed by local government. So the the ununiform capacity of the management can pose us some difficulties regarding the output of this irrigation. Yeah. And I'm sorry if I still in Indonesia, yeah, but I will highlight some issues, yeah. So the rapid development of reservoir now lead us to support for about 50 million people. Now we have more than 270 million people in Indonesia, yeah, and also
Please unmute Dr. Hadi.
So I will repeat again. So this poses some difficulties regarding the reservoir. We need to promote more reservoir in Indonesia, not only the artificial one, but also the natural one. So we have many lakes, and we also have a groundwater aquifer that should be promoted to sustain our water use. Yeah. So I think this is issues that cited by our regional planning, yeah, our medium-term planning. Yeah. So other issues regarding the water supply. So the capacity of infrastructure is still below the need, and the pipe network is still less than 20%. So it means that people still look for other source for the water supply, a clean water supply, and non-revenue water is about 33%. So many of the pipe network has some losses in the process, yeah. And I think the amount of 53% of the majority of household is depending on the groundwater. So this is quite figures, yeah, because we are somehow failed to contribute in the surface water regarding the pipe network. And the other issue is regarding the water quality. We have, like I mentioned, 65% of river is polluted. In Jakarta alone, we have 45% of groundwater in Jakarta is polluted, yeah, by especially fecal coliform, and 80% by Escherichia coli. So this is quite scary figures. And also land subsidence is happening in north coast of Java. The figures is up to 28 centimeter a year. The cause is natural and anthropogenic, yeah. But the fact is that we have this hazard, so we need to deal with this. So this is the issues that happen in Indonesia. Yeah. And in ITB, I think the water issues is covered not only in our faculty. Yeah. It's vary between faculties. Yeah. So our college from the Faculty of Earth Science, for example, is dealing with the atmospheric hydrology, and then also oceanography, and also groundwater, and also mapping and geology. And our college from the School of Informatics, we still need the informatic and communication system, because in our water law, Indonesian water law, we have 5 pillars for the water management. The first pillar is water use, The second pillar is the control of the destructive force of water. The third pillar is water conservation. The fourth is the people participation, and the fifth is the information system. Yeah. So I think all of the school and faculty in ITB is contribute to all the pillars. Yeah. And for example, college from the SPM or Faculty of Art and Design maybe can help the water management regarding the people, yeah, people management, yeah. So this is the mapping in ITB, I think. So I would like to also highlight some of the example of the research, yeah, field that we are conducting in our faculty, especially in our water research group. And the first is we have issues regarding the National Water Resource Information System. Yeah. So the water data is still kept by sectors. Yeah, not in the same platform. So we need to promote road mapping toward the same platform of National Water Resource Information System. Yeah, so we are not confused about the decision-making process. Yeah, and I think many of the research is leading toward this activity. Yeah, and then real-time monitoring system. I think our college from the physics department is already initiate this real-time monitoring system. Yeah. And also in our research group also. And also we are dealing with the national standard code support. As you know that we are still improving our codes regarding the water development. Yeah. So I think these activities or this research that support that activity is what should I say, bundled in the hydrology modernization. Yeah. So I think this is quite big in the next few years, I think. So we need to put more energy in this activity. Yeah. So I think the second issue is smart water management. Smart water management regarding the we have very abundant of water resource, however unevenly distributed. Yeah. For example, in Java and Nusa Tenggara, we have very quite stressed condition of water resource. Yeah, and not only about water use, but also about the hazard control. Yeah, for example, flood warning system. So I think many of the research is leading toward this one. For example, our student and our colleagues carried out the machine learning based flood warning system. So maybe we are now interested on the output base. Yeah, we need the accurate output instead of the physically processed set. Yeah. And regarding the decision support system, we also have multi-objective optimization, real-time reservoir operation, and full-time operation scale. Yeah. So this DSS is quite interest many youngsters. Yeah, many students dealing with this topic. And also smart irrigation and smart water supply management. Yeah. So because in our water research group still only in the quantity, yeah, focus on quality. Maybe our college in quality, yeah, in dealing with the other tactic, yeah. But in my research group, we are dealing with the quantity, and therefore we are interested on the non-refined water reduction. Yeah, how we invest in the operation and maintenance regarding the pipe network infrastructures. And also hydropower. We have many mountainous area in Indonesia. Some of them lies in the small island, so it has some potential for hydropower to self-sustain the energy in those areas. Yeah. As you know, we have 1% of the gap in the electricity ratio, so it's quite a number. 1% is almost 2.5 million people, yeah, not covered by electricity. So we need this kind of technology that identify the potential of hydropower, and we can be done it by remote and very efficient way. Yeah. So, and we also have a pump storage in our campus, and we are working on the optimization of the operation of pump storage. I think in the next few years we will have a few students that dealing with these topics. Yeah. And the climate change, like Prof. Sen mentioned earlier, also interests us. But in our group, we are considering about the quantity again. So we are concerned about the dependability of our current reservoir. Yeah. Can we still support our needs based on the existing reservoir? We have an increase of water, decrease of water. We can see based on the variable forecasted on the scenarios of the climate change. Yeah. So I think this is the research that we are doing right now. Yeah. So, ladies and gentlemen, I think in ITV we are working towards good cooperation between faculties and also between research groups. And I have strong confidence that in the near future we have lesser barrier between us, and we can work together to address those big issues. Yeah. So I think that's all my presentation. Thank you, ladies and gentlemen, for your attention. I return to Bu Mahat. Bye-bye.
Thank you, Mr. Hadi, for the presentation. And the next agenda is World Environment Day quiz from ACS publication. This session will be conducted by Ms. Mandy Sam. So Ms. Mandy, time is yours.
Okay, thank you everyone. I'd like to share with you. Okay, today actually our event is in conjunction with the World Environmental Day. So we played the video earlier, and we like to start with the sessions to make it fun. Yeah, World Environments, I think we not celebrate within the day, but we do it, I think, throughout our year and throughout our all area. Okay, I would like to have my colleague Elise. Okay, Elise, we're going to go through how we're going to go through these quiz sessions. Hi, Elise.
Yeah, so here are the game rules. The fastest person to get the correct answer will be chosen for each question, and we'll be picking different winners for each question. To qualify, please type your answer in the chat box below. And also we'll reserve the right to decide the correct answers and also the winners. And the winners, please remember to stay on at the end of the webinar to provide your details for us to give you your prize. And also we have 8 questions, plus 8 Grab vouchers to be won. Each will be 100K rupiah equivalent. Thank you. Over to you, Mandy.
Yes, I think our question is very, very straightforward. And the first question is, okay, please get ready and put your answer into the chat box. When is the World Environmental Day? The date. When is the World Environmental Day?
Okay, we got a winner.
Okay. So the answer is 5th June. So we encourage everyone to participate into it so that you'll be entitled for the prize. Okay, the answer is 5th June. So World Environmental Day is celebrated annually on 5th June, and it's the United Nations Principles vehicle for encouraging awareness and action for the protections of the environment. Okay, and first having in 1974, it has been a platform for raising awareness on environmental issue. Okay, so that will be a great concern for us. Okay, next question. Poaching is a severe threat to elephants. How many elephants are killed for their tusks per day? Any answer for that?
Not yet.
Within the range, yeah.
Yeah, we got a winner.
Yes, we got a winner. So the answer is 100 per day. So just make it fun, or somebody put 15,000, it'd be too many. Okay. Poaching has been defined as the illegal hunting for capturing for the wild animals. Okay, elephant numbers have been dropped, okay, by 62% over the last decade, and they could be mostly extinct by the end of the next decade. So we do the estimations, about 100 African elephants are killed each day by poachers seeking for the ivory, the meat, and the body part, okay, leaving only about 400,000 elephant available. So this is just for the awareness. So 100 per day is quite a lot. Okay, the next questions. Which land-based ecosystem had the most biodiversity? Which land-based ecosystem? So the type of the
Yep, we got a winner.
Yes. Okay, the answer is tropical rainforest. So I will let Elise to choose which one have the correct answer for this. Okay, worldwide, the tropics contain the most biodiversity, with rainforests being the areas that are the richest in the species. Okay, although the tropical rainforest only covers 6% of the Earth's surface, they contain 1/2 of the 3/4 of the world plants and animal species. So we will be happy that we are living in the world of this tropical rainforest here. The next questions. How many trees does it take to provide a day's supply of oxygen for 4 people? This is very, very tricky questions. How many trees does it take to provide a day's supply of oxygen for 4 people? Less than 10. Give some hints. Yeah, we know we depend on the tree size, but we say just a guesstimation based on the research. Less than 4. We still haven't get the answer yet.
Hey, we got a winner.
Yeah, don't be so serious here. So because we are reading this according to the North Carolina State University report, one large tree, we're talking about the big tree here, is able to supply a day's supply of oxygen for 4 people. Trees are also be able to absorb up to about 48 pounds of carbon dioxide a year. So this is just the number. So we can visualize, okay, one tree supply, okay, oxygen for 4 people. So imagine that we encourage more, okay, planting and more tree plantings in our neighborhood. Okay, so this is the answer 1. Okay, we have a few more to go. 4 more questions. How many % of the Earth's land is covered by forests? How many %? Okay, so we are according to the World Wildlife Fund's report.
Yep, I think we got a winner here.
Okay, so the answer is 31. I think we find the closer answers here. According to the World Wildlife Fund, 31% of the Earth's land is covered by forests. Okay, forests produce oxygen and provide homes for both the people and animals. So forests also provide food, waters, clothing, traditional medicines, and all the carbon sinks for us. So this is the closer answer we get. I think we get the correct answers from the audience. Okay, the next questions. So we have total 8 questions here. So 2 more to go. Whoever haven't put in the right answers. Okay. So whales can live a long time. How long can the oldest whale species live? How many years? So we're talking about years. More than 100? Oh,
I think we got winner.
Yeah, we have an answer. The answer is 200 years. So we do the estimations 200 years. Okay, we are referring to the bowhead whales can live over 200 years. Okay, whales are some of the largest animals on the planet. Okay, without correspondingly large protection on them, we might be watching some of them iconic species. Okay, will be extinct. So we just want to create some awareness. Okay, based on this quiz, you can imagine whales can live 200 years. How many of the human people have seen it before? It could be our older generation sees the whale that we are seeing right now. Okay, 2 more questions to go. How many liters of seawater it takes to desalinate to 4 liters of the fresh water? So since our today topic is on the water research, so it will be a concern. Okay, how many liters of fresh waters? Okay, we need to do it. Okay, to take it to 4 liters. Okay.
Yeah, we got a winner here.
Yes. Okay, the answer is 8 liters. Okay, based on the research. Okay, energy is the largest single expense for the desalination plants. Okay, according as much as half of the cost to make the drinking water of the sea. So based on the source, okay, we are talking about 8 liters of the seawater to make 4 liters of the fresh water. It means half of the volume for us, okay, in order to have the fresh water for us to drink. So you see, whatever water right now we are drinking is very precious to us. Okay, last questions. In many areas, what percentage of the coral covers have died in the past 30 years? So we are referring to the report. Okay, how many percent? Okay, we have the answer. At least you managed to find the answer.
Give me a second. Yep.
Yes, I think at least managed to find the answer. The percentage is 50%. So coral reef are the home for about 25% of the marine life and a major source of the food to more than 500 million people. Okay, however, coral reef are being damaged by the harmful fishing practice, pollution, marine debris, and the oceans warming. So in the past 30 years, 50% of the corals have died, and it projected that 90% will die by 2050. So this is very critical for us, okay, to be more cautious about the environments around us. Okay, if you look to the World Environmental Day video just now, you'll be able to see, okay, at the snap of the hands, a lot of things start from us. Then we reach out to the whole protection for our own community. Okay, I think that's the end for the questions. Okay, and we will identify the winner from the chat box. Hopefully, at least you get all the name, and whoever win the answer, at least you identify it. You manage to find.
Give me a second. Let me.
Okay, well, at least sorting out the answer. Okay, we're going to share with you. Encourage most of the participants. Okay, feel free to look into our ACS Insight. This will be a newsletter that basically we capture the latest publications or the news about the Southeast Asia country. So you'll be able to have a platform to showcase. If you have any of the event, you feel free to inform us. So we'll be incorporate inside is a part of the event, and also we extract what will be the publication from our Southeast Asia authors. Okay, that will be the session from the work quiz, and I wait for Elise to manage to identify most of the winner.
Yeah, so the winners are Kashik Yokogawa for the first question, Wong Li Ying for the second question, Robert Bachman for the third question, Gokula Krishnan for the fourth question, Liberat Payao for the 5th, Giovanno Elvin S. For the next one, Farawati Inshabella, and also Anand Kamil for last question. Please stay behind. Thank you.
Yeah, thank you, Elise. Okay, I'll pass it back to Ms. Maha.
Yes, Miss. Okay, thank you, Ms. Mandy. Now we come to the end of the event. I would like to invite Ms. Mandy to give a speech closing speech. Please, Ms. Mandy, to give us.
Okay, thank you very much. I think for my closing remark will be a very straightforward. Thank you for all the effort made from the LBBM. This is a first effort that we do the collaboration for this event, and I would like to thank both Shane Snyders have been so supportive, okay, to our event and giving the water research the latest update about these regions. And I would like to thank the speakers, Dr. Hadi will be the moderator, and also will be able to connect us with the latest update, the research area from the ITB. Okay, and also like to thank Dr. Rino to give us the platform, okay, to showcase our content at the same time to share some fun activity. And we like to highlight to the group of the participants, if we have ongoing events, okay, we're planning for some activity, the ACS on campus in this year. So most likely we do it in September and October. We share this activity to you, and we encourage you to sign on to our ACS Insight newsletter. Then you'll be able to see the latest information. At the end of the sessions, we're going to provide the certificate to all the participants, okay, whoever attends and register with the name inside. And my colleague Elise will contact the winner. Okay, the winner, please put your email address then so that we can able to match. I think she read out the name. Yeah, you can put the email address, then she'll be able to identify and connect you. Okay, thank you very much all, and have a good day. And we really appreciate your attentions, okay, for the whole event. Thank you.
Thank you. Bye bye.
Thank you, Ms. Mandy.
Thank you, Mandy. Thank
Thank
you
you.
all.
Thank you all. Bye bye.
Thank you, Pak Adi.
Nuhun Pak Rino, Prince, Prof. Sain. Sehat ya Pak ya?
Ya, sehat-sehat selalu.
Ya, saya pamit ya. Terima kasih.
Silakan, Pak.
Thank you for everyone.
Thank you, Pak Dekan.
Thank you very much.
Thank you, Mandy.
Thank you. Thank you, everyone.
Dr. Jenny, how are you?
Okay, we managed to get all the, at least you managed to get all the name.
Yep, Dr. Jenny. I'm getting their email address now.